Welcome to today's lesson, Exponential and Logarithmic Equations. We're going to start by using the one-to-one property of exponential functions to solve exponential equations. And this basically says that if b to the s equals b to the t, then s has to equal t. So let's use that for example 1. Solve 4 to the 2x minus 1 equals 8 to the x. So the idea of this one-to-one property is that if I have an exponential expression on the left with the same base as the exponential expression on the right, I can set the exponents equal to each other. Well, right now I don't have that. 4 and 8 are not the same base, but they can both be written with a base of 2. 4 is equal to 2 squared, and I'll raise that to the 2x minus 1, and 8 is equal to 2 cubed, and I'll raise that to the x. Now remember, raising a power to a power means I'm going to distribute, and I'm going to get 2 to the 4x minus 2 is equal to 2 to the 3x. Now that my bases are the same, I can set the exponents equal to each other. 4x minus 2 is equal to 3x. If I subtract 3x and add 2, I get that x is equal to 2. So that was one way we can use to solve exponential equations. But sometimes you can't rewrite both sides with the same base, and we have to use logarithms to get the variable out of the exponent. So for example 2, we're going to use logarithms to solve. In A, we've got 4e to the 2x plus 5 is equal to 12. So the first thing I have to do is isolate the exponent. So I'll subtract 5. So I got 4e to the 2x is equal to 7. Then I'll divide both sides by 4, and I have e to the 2x is equal to 7/4. Now that I have isolated the exponent, I'm going to use natural log because that is the inverse of e to the x. So I'm going to take the natural log of both sides. Now we know that the natural log of e to the 2x just simplifies to 2x. That's equal to the natural log of 7/4. And then if I divide both sides by 2, I get that the x is equal to the natural log of 7/4 divided by 2. And if I put that in my calculator and I round to 4 places, I get 0.2798. Part B, I've got 5 to the x minus 2 equals 3 to the 3x plus 2. Again, I can't write these with the same base, so I am just going to take the natural log of both sides. I'm using natural log here because I have a natural log button on my calculator. You could also use common log. So I'm going to say the natural log of 5 to the x minus 2 is equal to the natural log of 3 to the 3x plus 2. Now I hope you realize that the reason I did this is then I can use the power rule to bring that variable out of the exponents and make them factors. So this turns into x minus 2 times the natural log of 5 is equal to 3x plus 2 times the natural log of 3. So I'm trying to isolate x. The first thing I have to do is distribute. So I'm going to have x times the natural log of 5 minus 2 times the natural log of 5 is equal to 3x times the natural log of 3 plus 2 times the natural log of 3. I know this looks kind of messy, but whenever we're solving for a variable, we move all the terms with x on one side and all the other terms to the other side. So I'm going to start by subtracting 3x times the natural log of 3 to put it on the left side. So I'm going to have x times the natural log of 5 minus 3x times the natural log of 3 is equal to, and I'm going to add 2 times the natural log of 5 to both sides to move it to the other side, and I'm going to have 2 times the natural log of 5 plus 2 times the natural log of 3. Now I'm going to factor an x out of both terms on the left, so I'll have x times the natural log of 5 minus 3 times the natural log of 3 is equal to 2 times the natural log of 5 plus 2 times the natural log of 3. And then finally I will divide both sides by the natural log of 5 minus 3 times the natural log of 3. So we have 2 times the natural log of 5 plus 2 times the natural log of 3 over the natural log of 5 minus 3 times the natural log of 3. If if I put that into my calculator, I get that x is approximately equal to negative 3.2116. Just like we can use the one-to-one property of exponential functions to solve exponential equations, we can use the one-to-one property of logarithms to solve logarithmic equations. So this basically says that if log base b of s is equal to log base b of t, the bases have to be the same, what's inside the logs can be set equal to each other. S has to equal t. Now this is important. When solving an equation involving logarithms, always check to see if the answer is correct or if there is an extraneous solution. So example 3, solve the natural log of x plus the natural log of x minus 4 equals the natural log of x plus 6 using the one-to-one property of logarithms. Now keep in mind the one-to-one property says that you have to have a single log on the left and a single log on the right. Well, I have two separate logarithms on the left being added together. So I'm going to have to use my properties of logs to combine them into one log. So because they're being added, this is the same as the natural log of x times x minus 4, and that equals the natural log of x plus 6. Now that I have a single log with the same base on both sides, I can drop the logs, and I have x times x minus 4 is equal to x plus 6. So I'll distribute and I get x squared minus 4x is equal to x plus 6. Since this is a quadratic, I'm going to have to move everything to the left, so I will subtract x and subtract 6, and I get x squared minus 5x minus 6 is equal to 0. I'll factor this, and the factors of negative 6 that add up to negative 5 are x plus 1 times x minus 6, which gives me the solutions x equals negative 1 and x is equal to 6. Now remember, we were warned to check and see if we have extraneous solutions. So basically what this means is we've got to plug x equals negative 1 and x equals 6 back into the original equation and see if we are not in the domain. Well, it looks pretty simple. If we plug in a negative 1 into the natural log of x, I'll be taking the natural log of negative 1. That's a negative number, so x equals negative 1 is not an answer. Now let's try 6. When x equals 6, the natural log of 6 is a positive number, the natural log of 6 minus 4 is a positive number, and the natural log of 6 plus 6 is a positive number. So x equals 6 is my only solution. Example 4, we want to solve without a calculator. A, the natural log of x squared is equal to the natural log of 2x plus 3. So here we're going to use the one-to-one property of logarithms because we have a single natural log on the left and a single natural log on the right. So I can just set x squared equal to 2x plus 3. I'll subtract 2x and 3. I can factor this, and I get x plus 1 and x minus 3 is equal to 0, and this gives me the solutions x equals negative 1 and x equals 3. Now don't just assume that negative 1 gets tossed out because it's a negative number. Let's see what happens when we plug negative 1 back in for x. Well, negative 1 squared is positive 1, so the natural log of 1 exists, and if we plug negative 1 in for x here, that's negative 2 plus 3, which is also a positive 1. So x equals negative 1 is a solution. Now let's see if 3 is also a solution. If I plug 3 in for x squared, the natural log of 3 squared is 9, and if I plug in a 3 over here, the natural log of 6 plus 3 is also a positive number. So this actually has two solutions, x equals negative 1 and 3. Part B, log base 6 of x plus 4 plus log base 6 of x plus 3 equals 1. Now this one is different. I don't have logs on both sides. I just have logs on one side. So I can't use the one-to-one property. But what I can do is I can at least combine the two logs on the left together by using the product property. So that means I've got log base 6 of x plus 4 times x plus 3 is equal to 1. I can distribute and I get log base 6 of x squared plus 7x plus 12 is equal to 1. And now that I have a single log equaling a number, I can just slide the base and drop the log and turn this into an exponential equation. So I'm going to slide my base of 6 to the right and drop the log, and I get x squared plus 7x plus 12 is equal to 6 to the 1, or 6. I'll subtract 6 from both sides. So I've got x squared plus 7x plus 6 is equal to 0. The factors of 6 that add up to 7 are x plus 1 and x plus 6, which gives me x equals negative 1 and x equals negative 6 as my two solutions. So when I plug negative 1 into x plus 4, negative 1 plus 4 is 3, which is positive. And if I plug negative 1 into x plus 3, I get negative 1 plus 3, which is also positive. So x equals negative 1 is a solution. But if I plug in negative 6, if I plug in a negative 6 here, negative 6 plus 4 is a negative number, and that is outside of the domain. So negative 6 is not a solution, so our only solution here is x equals negative 1. That's all for now. Thanks for watching.